Thank you.
Well, what I'd like you to do is maybe just give a little biography of yourselves. I know that you're modern Orthodox rabbis, but I then would like you to maybe divide up your time and talk a little bit about fine tuning.
Okay, great. So I guess I'll introduce myself. I'm Elie. So I guess I grew up, some background, I grew up in, I guess, a modern Orthodox home. And that means we had a strong commitment to religion, but at the same time we had a strong commitment to the world and to science. My grandfather was a rabbi and a chemist. My father is a rabbi and a lawyer. And again, my upbringing was very much about the interplay between my religion and my involvement in the outside world. And I never saw it. I never was brought up in a way that there was any conflict or any problem with this. I was always like a math guy. When I was a kid, I was that like math whiz in the class who was annoying and whatever. So that was me. And sure enough, once I went to college, it became natural for me. Again, I did want to follow in the footsteps of my father and my grandfather of becoming a rabbi. But at the same time, I was very interested in mathematics and I was good at it. So I ended up going for a degree and a PhD in math. And currently, I'm a professor. I'm a math professor at a community college in New York. And I'm a rabbi. I teach in a yeshiva that's like post-high school students where I teach a class. And very much, again, Aaron and I have been good friends, and we have a lot of conversations which involve the interplay of religion, theology, and of physics and science. And yeah, so that's a little background. And then we've made, again, as Ken mentioned, I'm sure we'll talk more about it, but we started this podcast about 2 years ago or so, but it's based upon the culmination of work we've been doing for, let's say, 12 years or so about the physics, God, fine-tuning. Yeah.
Right. My name is Aaron Zimmer. I also, modern Orthodox, also grew up. I was raised in that way. For me, I guess the difference between Elie and I is for me, I've always sensed the tension between the modern world and religion, and like in various different ways, culturally, intellectually, through the conflict between science and the worldview of science, and really the worldview of religion, which is just seemed to me when I was growing up as a teenager, like diametrically opposed in terms of their values. When in college, I pursued a physics degree. And I didn't go for a PhD in physics or postgraduate school for a couple of reasons. One is I wanted to explore many different areas. I'm like interested in philosophy and psychology and economics and history, and it's just when you specialize in one area, you almost limit yourself. You're forced to like limit and. Since the nature of knowledge in the modern world is it's hard to really practice a general broad base of knowledge. You kind of are forced to specialize. So I didn't really want to do that. I wanted to find a way to support myself independently of working in the world of academia. I ended up trading commodities. I was fortunate. I used the the ideas of physics, the idea of modeling and quantitative analysis, in order to study commodity markets and to model them, really based upon, it's hard to describe, different patterns borrowed from the categories of physics, together with a conceptual approach that I learned from studying Talmud through the Brisker methodology, kind of combining those two to trade commodity markets, oil, gas, cotton, sugar, coffee, corn, a lot of different food, and other items. And I was able to retire, I guess, about 6 years ago. I did it for about 11 years. And now I study Talmud. I learn philosophy and science, physics in particular, but just really all areas of science. And Elie and I have been working on this podcast, Physics to God, for the past year. We've been writing a book we're still working on for the past 12 years.
Well, excellent. I want to remind our scholar community that they're going to take some questions, so make sure you get them into the chat. Elie and Aaron, I know that you, like myself, are engaged by this fine-tuning argument, And I think you want to share a little bit about differing perspectives of the fine tuning of the universe. So I'm going to let you take the discussion.
Okay.
Okay. So one thing we came across that I think is not it's not broad public knowledge is that there's different versions of the fine tuning argument, different ways that it can be presented. And it's not just one monolithic way of formulating it. And it really matters. It really matters how it's presented. And the different ways of formulating it lend themselves to certain problems. And oftentimes when you see atheistic scientists attack the fine-tuning argument, they're really attacking one specific form of it. So
basic idea, fine tuning.
Okay, so let me. Okay, that's true. I don't know how many people are familiar with that. So let me give a. Why don't you go?
So just the most basic short version. Again, we thought there's a balance here, but let's give the basic idea of the fine tuning argument just to make sure we're all on the same page, and then we'll talk a little bit about different versions of it. So the basic idea are these numbers, quantities in the laws of nature, maybe the mass of an electron, or the fine structure constant, which determines the force between two electrons. And these numbers are very, very specific numbers, like 1 over 137.1399137, I don't know, very, very precise numbers. And it was discovered, again, the nutshell of the fine tuning argument, it was discovered recently over the last, let's say, 40, 50 years or so, that these numbers are fine-tuned, which means if the numbers were a little bit different from what they actually are, fundamental physics would still work out, but it wouldn't result in everything else, all the complexity in our universe, whether there wouldn't be galaxies, there wouldn't be stars, there wouldn't be planets, there wouldn't be life, there wouldn't be atoms and molecules. And it's like our amazing universe is dependent upon these numbers being precisely the way they are, fine-tuned, if you will, and not to be any of the other possible values that they could have been. That's the nutshell of the fine-tuning argument.
Okay, good. That's what we got Elie here. He's the one who clarifies, makes things simple. So I'll try to make it a little complicated, and he'll make it simple. So so there's really three approaches. We're going to present three approaches today. One is going to be an argument from elimination. That's the first one. The second one we're going to call the probabilistic formulation, and the third one is the way that we're doing it. We probably should have a good name for it. We'll call the argument based upon the mystery. Okay, we'll call for the mystery. So the first one is an argument from elimination. This is one I think that it's probably the easiest to present. It's where you basically say, we've seen this in a few different places. I think we've seen William Lane Craig has a video on the internet about it. Basically says, how do you explain fine-tuning? There's a problem. These numbers are precise numbers that are necessary for, usually it's said for life. That we'll discuss this at the end about whether it's for life or other things. That's a second difference we do. But saying that these numbers are necessary for life, how do you explain them? The problem of how you're explaining fine-tuning. And essentially says there's three possibilities. Either it's necessity, the numbers just have to be that way for some reason or the other, or it's just chance, which ultimately boils down to the multiverse, a theory of an infinite number of universes with different constants and different numbers, and then by chance one of the universes is going to happen to have the right values, the ones that we see, and of course we live in the universe which has the right constants because we couldn't exist in any other universe. That would be the second possibility. And the third possibility would be design, some sort of intelligent cause that set the values for the purpose of, often it's formulated as bringing about intelligent life. And then the argument proceeds to say, well, let's see if we can eliminate two of these possibilities and we'll be left with one. So the argument is let's eliminate necessity. There's no logical reason why these numbers have to be that way. I mean, the numbers are, again, 1 over 137. What kind of logical reason is there? These numbers from the framework of physics could be anything. Why should they logically have to be that way? And therefore, it's more or less dismissing the possibility of necessity. And then in terms of multiverse, the second possibility of chance, multiverse is not a good theory for various reasons. One is something called the measure problem. I'm not sure how deep people usually get into it, but ultimately, when you try to turn multiverse into some sort of real concrete theory, it has to maintain that we live in a typical universe with intelligent observers, and we don't live in the typical observer would either be just one solar system with a planet, or maybe even just a disembodied brain, something along those lines. And basically the multiverse is not a good theory. That's not supported by evidence and whatnot. So they eliminate those two possibilities, and then you're left with an intelligent designer, intelligent fine-tuner as the cause of the constants. That's the first approach, the argument from elimination.
Okay, so maybe I'll pick up the second approach, and this is, I guess, the first approach from elimination is very easy to say over, and you see the three possibilities. Some like to present it in a little bit of a more rigorous way, which is, instead of just saying the first two possibilities, the idea of necessity or the idea of chance, are rejected outright, they say, well, it's not quite rejected outright, but instead they try to explain it from, a Bayesian probabilistic standpoint. And they say, let's say we have two rough possibilities that one theory could be the theory of God, an intelligent cause, however you want to say, theism, and the other possibility could be naturalism. And the question is given these two theories, now we have before us the information that the constants are fine-tuned, and they say, what's the probability, given the theory of an intelligent cause, what's the probability that the constants would be fine-tuned for life and for our complex universe? And on the other hand, given the theory of naturalism, what's the probability that we would get these fine-tuned values? And the idea is to try to weight these two possibilities, one against another. And the reasoning goes, and again, this is done different ways by different people, given the idea of a God, it seems to be relatively likely or within reason that God would create a universe like our own, a complex universe. But given naturalism, it seems to be very, very improbable that we would get these numbers to be fine-tuned exactly in a small life-permitting range by chance alone. And by comparing these two probabilities, they try to make the argument a little bit more rigorous. This is an approach which is taken in different ways by Luke Barnes is one person, or Robin Collins, and again, there's various ways. And again, it's an attempt to, using probabilities of Bayesian analysis, to be able to make the argument a little bit more solid than just to say we've outruled necessity and we've outruled chance, and therefore the one possibility left standing is that of a design.
Okay. That's the second approach. Yeah, I see the question. We're going to take up, to some degree, just, there's in a sense a little bit of bias here. We're going to be presenting these approaches. We like to present approaches as well as we can initially. We're going to give our approach, and then we'll come back and we'll critique what we think are the lackings of the other ones, and why we think our formulation is better and doesn't lend itself to the same problems. Okay, so let's. So our approach is the key shift is to realize that fine-tuning is not the problem. Okay, when you look at fine-tuning as a problem, you end up with these other approaches. You say fine-tuning is this problem. How do you explain it? There's three possibilities. Let's eliminate two of them. Or in the probabilistic approach, fine-tuning is a problem. How can you explain it? Either it's God or it's naturalism. What's the probability if it's God? What's the probability if it's naturalism? But either way, you're starting with fine-tuning being the problem. We think conceptually it's important to note that fine-tuning is a solution to an intrinsic mystery that exists in physics. Nothing to do with fine-tuning. So we often ground it in Richard Feynman has a great quote where he talks about trying to explain the value of the fine structure constant. And he's talking about quantum electrodynamics, which has nothing to do, it's just a quantum formulation of electromagnetism. And he's nothing to do with fine-tuning. It's even before fine-tuning was really discovered, prominent at all. And the question is, scientists are trying to explain the universe. They're trying to explain the world. They're trying to explain all the laws of nature. And they're looking to unify that and to find a simple theory that would explain everything that we see around us. And when they have these beautiful theories, quantum mechanics being, primary example, together with general relativity, part of these theories are these numbers. And these numbers are just these arbitrary from the framework of physics, and in 1985 when Richard Feynman wrote this, it's just these like arbitrary numbers, 25 ugly lists of data, and how do you explain that? It's scientists are looking to for a fundamental basis of all reality. And what they've discovered is quantum mechanics, a qualitative set of relationships, plus 25 numbers. And that doesn't sit right with any physicist, as that is the ultimate bedrock of reality, is 25 arbitrary, ugly-looking numbers. And the problem is the mystery, what Feynman calls one of the greatest damn mysteries in physics, is how can you explain a number? What is the approach? What qualitative theory of physics is going to pop out a number like that? And that's just a mystery. It's a problem in physics of how do you explain these crazy numbers. Nothing to do with fine-tuning. And that's an important point. What happened is, over time, scientists started to realize that the numbers were not arbitrary, but that the numbers are fine-tuned, that they have to have their specific value in order to produce galaxies. You need, this is really in 1998, was when everything changed and for cosmologists and physicists, the discovery of the fine-tuning of the cosmological constant, which is the number that regulates the expansion rate of the universe. And it's fine-tuned to 120 decimal places, which is a fantastically tiny number. If it was too big, the universe expands too quickly, no galaxies form. If it's too small, the universe contracts too quickly. I think I just reversed it. Either way, and no galaxies form. And so the same thing with many of these other numbers, that you find that they have to be within certain ranges. What that does is it provides a clue to solving the mystery. The mystery of the constants is, how do you explain these 25 crazy, arbitrary, seemingly senseless numbers? And fine-tuning is a clue which shows you that these numbers are not arbitrary, but the numbers have a purpose. There's a relationship between the value of the numbers and the resultant universe. You can see how if the fine structure constant was different, there would be no atoms and no molecules. If the cosmological constant was different, there would be no galaxies. If the mass of an electron was different, again, you wouldn't have any atoms, because whatever. We don't get into details. So you see that fine-tuning is knowledge, is scientific knowledge. The more and more scientific knowledge you have, the more scientists understand about fine-tuning. And it's now that knowledge provides the clue to explaining, answering the mystery, which shows that the cause of the constants is a cause that can set them for a purpose, for the purpose of producing atoms, molecules, life, planets, stars, galaxies. And that shows you that the cause of the constants is intelligent, because it operates with a purpose. It knows, so to speak, what is going to result if it makes the fine structure constant 1 over 137 as opposed to 1 over 139. It understands that, and it set it for a specific purpose, which indicates that the cause is intelligent. Insofar as it operates with a purpose, it selected a specific value for the purpose of achieving its objective. That's more or less the gist of our approach of showing how fine-tuning is not the problem. Fine-tuning is the clue which points the solution of an intelligent cause to resolve the intrinsic fundamental mystery of the constants that exist in physics, independent of fine-tuning.
Great. So given these three approaches, maybe we'll just talk a little bit about the, the strengths or weaknesses, or what questions one might have on the first two approaches, and why we think the way we're formulating the argument in physics to God is more robust, if you will, more convincing. And that is, I guess, if we start off with the approach of eliminating the possibilities, and that idea is that the starting off with that there's three possible ways to explain fine-tuning. Again, this way is we start off with the fact of fine-tuning, and how do you explain it? Either it's necessity, that these numbers have to be fine-tuned, or chance, or a designer. And I guess what strikes us as somewhat unconvincing, I think as other people also, is first of all, the argument only works, you need two things. First of all, you have to be convinced that this list is exhaustive, that those are really the only three possibilities. And it's not necessarily clear. In fact, one of the possibilities that have necessity, we think there are really two ways to formulate that, which are very different and have to be dealt with, treated independently. But more generally, it's a symptom of the fact that the whole thing only works assuming the list is complete, and it's not always so clear. Maybe there's other ways. For example, there's at least Smolin has a theory which tries to explain the constants through something called cosmological natural selection. And sometimes to say that we've listed all the possibilities, it's not always clear that your list is complete.
Well, let me just on that one, the cosmological natural selection, just so you understand that ultimately it doesn't really work, Smolin's theory. But just, you think you have a complete list. It's either it has to be that way, or it's just chance, or some intelligence said it that way. But ultimately what Smolin did, at least Smolin, a physicist, he did is he tried to use the solution, Darwin's solution for evolution in biology and apply it to physics. So he has this theory where, inside of black holes, what happens inside a black hole. He speculates maybe a new universe is born inside of a black hole, and each time a new universe is born in a black hole, the constants change. And they change by a little bit, which is where the flaw of his whole theory ends up becoming. He has to have some law to regulate how often it changes, which leads to requirement of meta laws that are fine-tuned. I don't want to get into what's wrong with it, and then it becomes like some sort of natural selection process where the universes become fine-tuned for producing black holes. And, essentially the universes will just naturally evolve to be the most, you'll end up with over time, you'll have universes which have the most black holes. So that's a thing where the constants are changing. They're not of necessity a specific value. They change over time. On the other hand, it's not random chance like multiverse because it's working through this law and this principle that it changes slowly, and there's a survival advantage in this cosmological framework. So it's like something in between. And now that's a really creative solution. Just like nobody really thought about before Darwin, evolution and natural selection. It's something creative which surprises people, and just once you see that, you say, well, it's kind of not on that list, the list of three possibilities. And even if you could disprove Smolin, well, what if maybe there's another possibility that you're missing? So just any time you're arguing from elimination, sometimes arguing from elimination it's simple, it's clear to give over, it's easy, and there's value in it, but it just always lends itself, there's an element of doubt of maybe I'm just missing a possibility, and that undermines the entirety of the argument because you're not directly proving to your final possibility, you're just really eliminating the others.
Right. Well said. So another problem with this approach is even assuming your list is complete, the argument from elimination is dependent upon convincingly eliminating the other possibilities. So the idea of chance, you could say chance is unlikely. Well, is it impossible? Is it really eliminated, or is it just not so likely? Or the idea of necessity. Necessity, it only works if you could really show necessity is impossible. Because if your whole argument is based upon the fact that we got three possibilities, we've shown those two are impossible, then God has to be true. Well, let's say you haven't shown that they're impossible, well, they're just there's questions on them. So now you haven't quite fully eliminated them. So even if your list is complete, it only works assuming you've rigorously eliminated those possibilities. And it's very hard to absolutely eliminate. Now that I think brings to the second approach, and why those who take on the probabilistic approach, I think this is part of what motivates them, is that they see that problem, is that you can't really fully eliminate the possibilities. You can just show it's very unlikely. Given the theory of naturalism, it's very, very unlikely that we would have our constants be fine-tuned by chance alone. Well, then you could compare that to a probabilistic approach. Well, given the theory of an intelligent cause of God, then how likely would it be that we would have our universe? And then they try to compare. Instead of just eliminating the other two, they try to make a probabilistic comparison. And this is like a Bayesian type of an approach, which is to say, given these two theories, what's the probability that we would have our fine-tuned universe? And whichever one is more likely, whichever theory would I guess more fit in line with the data which we observe of fine-tuning, we'll say that's the better theory. And they try to make a probabilistic comparison between these two different approaches.
Right. Now the the problem with that approach, it really exists on both sides of the probabilities, trying to really rigorously establish what are the probability of getting the constants given naturalism. That's one problem. The other one is given what is the probability of God deciding to fine-tune the universe to be something like our own. Both of those have their difficulties. Let's start with the one with the harder one a little bit. Well, they're both difficult. Let's start with the science one. So, is it really that easy to rigorously discover what is the probability that these constants would have their values by chance? And it's really not that easy to do because, I mean, all you really have is one example of the fine structure constant. We know it's, in our universe, 1 over 137 point something. So what is the probability it became that way? Hard to really figure out. What is the probability the mass of an electron is so tiny? I don't know. So how do you even start quantifying that? Okay. So now multiverse scientists have this problem too because they also try to use probability, and chance in order to explain the constants through infinite numbers of universes. So the method that scientists use, and this is, I think, what those who try to, present the fine-tuning argument through probabilities also use. It's clever, and it's you could argue it, but it has its problems. You try to make an upper and lower bound. So, for example, let's just take the mass of an electron. If you were to say that an electron can't be smaller than, obviously can't be smaller than 0, right? You don't want to have it can't have a negative mass. This doesn't really make any sense to have a negative energy or negative mass in physics. And it can't be bigger than there's a certain, a Planck mass where basically the particle becomes a black hole. It's no longer a particle, it turns into a black hole. Something along those lines. So you find upper and lower bound. And then now, what is the probability distribution between those? Is every single value in between the 0 and the Planck mass, are they just as likely? How do you know? It could be, a lot of times there's a distribution of probabilities where one range of values is more likely than others. But obviously that's impossible to do. The whole thing is you're speculating about a probabilistic range. So you have to assume a linear distribution. You have to assume that all values are equal in this range. And given that you can successfully try to make up upper and lower bounds and assume that the probability of every value in between is equally likely, then you can calculate the probabilities and it comes out that the odds are 1 in a trillion. It becomes incredibly unlikely. That's the most straightforward way to do it. It's the most honest way to try to do it. But it's really speculative. And people do criticize the approach because they say, look, we've only seen one value. Your whole saying that the odds of these constants are so 1 in 10 to the 120, whatever it is, your whole approach is flawed because you don't really know the probability distribution, and it's a legitimate criticism that this approach has. Can you really rigorously define the probability of every constant?
I guess, and then the other side. So now that's the way they say. That's the way they start there, and then they say, okay, well, given the theory of God, what's the probability that he would fine-tune our universe? And they say, well, I don't know. What do we really know about God? And they say, well, there's different ways to reason that God is good and he's all-powerful and he would want to make a universe like this, or arguments like that. And I think the problem with that type of approach is it's very hard to know what God would do. All we know is that we're talking about there being an intelligent cause of our universe, but to start saying is that we could figure out, or we could reason, or we could say, well, why would God want to do this, or why would God want to do that? We don't really have any way to put probabilities. Even if there is a creator of a universe, how are we to figure out or make a model or some probability function of what the likelihood or probability that he would make a universe like our own? It's kind of just shooting in the dark. We can't tell God what to do. We just see what he did and see what he created, and then say, wow, that's amazing. But it's hard to make this probabilistic comparison or a calculation, if you will, to say, given the theory of God, what's the likelihood that he would create a universe that looks like this? It's not. There's no real rigorous way to do it. So the idea is like this type of approach of making like a Bayesian analysis of the different theories, given these probabilities. It's like there's a lot of hand waving going on, if you will, is to try to assess, they're taking things which are not really subject to a solid, probabilistic computations, and to try to somehow put numbers, obviously there's not numbers, but to try to assess the likelihood of these different theories, it just doesn't quite, it often doesn't compel a person to, to really be convinced that this is really a better theory because it's more likely that God would create it, as opposed to a good make fine-tuning, as opposed to the naturalism.
Right. The other problem, and very often this probabilistic approach, which is the more rigorous version that's presented popularly, is criticized by scientists, is very often on this angle of what would God do. Like we saw Sean Carroll really go after this approach, and almost all his questions are always based upon, well, if I were God, I wouldn't make a universe like this, and how do you really know that? And it brings down the fine-tuning argument. It drags it into the mud. It really forces it to deal with problems that it shouldn't have to. For example, and it's legitimate questions when you formulate it this way, is you end up with the problem of evil. Now the problem of evil all of a sudden rears its ugly head. And, Sean Carroll's saying, well, why would a God who's all good make children who, have diseases and birth defects and natural disasters? And I'm sure you guys are familiar with all the problems that people raise against it. And if you have to be honest, is if your argument is, if given God, what is the probability he would make a universe like our own? Well, now you've created that problem for yourself by formulating the fine-tuning argument from an attempt to psychologize God and to figure out what God would do. Now you have to say, well, given God, what are the odds of him making a universe like our own? Well, then Sean Carroll's a good question. I mean, if God is all good and all powerful, why do he make a universe where anything but evil ever happens? And then you have to say, well, because of free will or whatever people want to say to answer these types of problems. It's just really an unnecessary baggage to start bringing the problem of evil into the fine-tuning argument. That just doesn't belong. It's not necessary. And you give physicists like Sean Carroll, they give them the high ground. You let them think they've disproven the fine-tuning argument because of an earthquake, and that it really it's a relic of the fact that you're formulating the fine-tuning argument through this attempt to give a probability that given God, he would make a universe like our own, which is, again, we don't think is necessary.
Right. So basically, our approach is let me explain a little bit now why we think the way we're approaching it avoids these problems. And the idea is that we're really starting off with a mystery. This is a mystery which has nothing to do with God. It has nothing to do. It's just a physics mystery. Richard Feynman, who's not discussing theism or atheism or anything, he's just trying to figure out physics. And it starts with this mystery about how do you explain the values of these constants. And good science leads to the conclusion, leads to the discovery of fine-tuning. Fine-tuning is the clue which helps us. The numbers are not just these random numbers as Feynman and others thought. They're not just, they could have been any old numbers and they happen to be these numbers. No, these numbers are precisely the numbers which are necessary to bring about our complex universe. And that discovery is the clue which points us, how do we understand these constants? And since the values are those values which are perfect to bring about the goal of our complex universe, that indicates a certain type of a cause. It's a cause which is like a teleological cause, a cause which the numbers are this way for the purpose of bringing about our complex universe in the future. And once we recognize that this is the way to explain, the fine-tuning shows us the way to explain the values of these constants, that leads us towards an intelligent cause. Because an intelligence is the type of a cause, and as an intelligent actor acts with purpose. And there's an objective. An intelligent cause acts with the purpose of bringing about a certain result. And because of the fact that we see the correlation between these values and the end result, it points to the fact, it indicates that the cause of these values is intelligence, not just some blind force which doesn't know what it's doing, but it points to the fact that it's a type of a cause which sees the end result of what it's bringing about and chooses those numbers which are precise to bring about that end goal. And that's kind of the idea that follows from the idea of the definition of intelligence. And intelligence is like a measure where a person of intelligence selects one possibility from the set of other possibilities for the purpose of bringing about some intended goal. And therefore, when we follow the clue of fine-tuning, it directly leads towards it indicates the idea that they're created by an intelligent cause.
Right.
So the point is, it's not starting with a problem and ruling out other possibilities. On the contrary, it's starting with a mystery and following the evidence and showing where it leads to. So it indicates, the idea is that fine-tuning indicates an intelligent cause. And while it's true there might be other possibilities which one has to take up, and like multiverse is another possibility, but since the argument directly points to an intelligent cause, we think we don't have to, the burden of proof isn't on us to outrule the other possibilities. The burden of proof is on an atheistic scientist to be able to present another cogent theory which explains that this is all an illusion, that fine-tuning is an illusion. It doesn't truly indicate an intelligent cause, but it could be explained by an unintelligent cause. And we go through that in a rigorous way to show why multiverse fails to do so. But we think that by starting with the mystery and the solution of how fine-tuning points in this direction, it changes the burden of proof to those who are trying to undermine the argument of an intelligent cause.
Right. Now let me explain a weakness of our approach. What's the weakness that it has? And then a general strength that it has besides the weakness of the other approaches, a general strength. So let's start with the weakness first. The weakness really lies in this concept of indication. So it's the idea that that when you have the evidence points to the simplest, straightforward interpretation. So we're arguing that there's an idea of an indication. If you have, or example that we use in our podcast, I forgot, maybe it's episode 10, we talk about the idea when you find a murder weapon, which has the fingerprints on the person, the suspect is at the scene of a crime. So the evidence points and indicates that, the suspect did it. Now, are there other possibilities? Maybe there's a conspiracy going on. It's true, and it's possible there's such a thing as conspiracies. They could happen. There just could be the illusion that this suspect, John did it, but he might have been that somebody else did it. So that's true. We agree the possibility of other theories, but there is that first. It's a type of Occam's razor in methodology that when all the evidence, when the evidence indicates something, that becomes your first theory. That's the simplest assumption. That's what your mind goes to. And there is a reality to the way the human mind works, that when the evidence all lines up and points to something, it indicates that, and that becomes, there's a certain primacy of that explanation. Again, it doesn't prove the other theories are false, but it creates, like Elie was saying, it creates a burden of proof. If you want to posit there's a conspiracy, there's something else that's creating the illusion that John murdered him, then you have to, the burden of proof is on the defense to support that by actual evidence. Likewise over here. The evidence indicates when you have all these numbers lined up exactly that in order to get a universe with atoms and molecules and stars, that indicates that the cause was intelligent. Now, if scientists want to maintain that it's really just an illusion of fine-tuning, and there's in a certain sense a natural conspiracy because there's an infinite number of other universes that nobody's ever seen, where the constants are all different, and there's no atoms and there's no molecules, there's no stars in these other universes. And it happens to be in one universe you have stars and you have atoms and you have life and all these things, and it just looks like that to us, where we're under the illusion that the universe is fine-tuned, and there's essentially a big cosmic conspiracy according to them. It's possible. They have to show that they have to provide justification. They can't, that there's an infinite number of universes, that the constants really do change, and that the typical universe that has intelligent observers is something like our own. And they can't just speculate that maybe there's an infinite number of universes and maybe the constants change and maybe the typical universe is our own. They have to actually provide justification for that. And when they try to do that, they end up having problems. They end up having problems when they try to justify it and establish multiverse with real justification. But it's important to see where the burden of proof is. Again, the weakness of our own is that you have to buy this idea that the human mind follows a type of Occam's razor when it analyzes evidence, and it sees that there's a simple, direct explanation which becomes the primary one, unless you could really show that the other explanations have some sort of support and justification to make you question that. The strength is like the God of the gaps. You want to say that part?
Yeah, I guess the strength is that because of the fact that we present our argument based upon a fundamental problem in physics. You see, I guess let me start again. Is that the way the other presentations start is they start out with fine-tuning and they say, Here's fine-tuning, how do you explain it? Well, there's 3 possibilities, let's eliminate the other 2. Or here's fine-tuning, and let's try to weigh the different probabilities. Given these 2 theories, which one is more likely to explain fine-tuning? And one might say you're just picking off one thing in our universe which we don't understand. And you might say that sometimes people raise it, that's God of the gaps type of a problem. That's just one thing in our universe that we happen to not understand. Maybe that's just something which we will understand as time goes on. But the way we present the argument, we show how this is not just picking out some detail, like the eye, how do you explain it? But this is a problem which emerges from fundamental physics. This is at the core of physics, is trying to find the unified theory of everything. And trying to explain, as Feynman said, this is one of the greatest damn mysteries of physics. How do you explain these constants? It's not just a gap in our knowledge, it's getting to the core of our universe. How do we explain the basics of our universe? And when we follow the clues naturally about explaining these constants, we've discovered that they're fine-tuned. And that leads us directly towards the idea, the fact that they have a teleological cause, which is a result of an intelligent actor. So it's not that when we realize we contextualize fine-tuning as the solution to a problem that lies at the heart of the foundations of our universe, it's clear that it's not just a gap in our knowledge that we're filling with God, but rather it's what naturally emerges from the most fundamental of scientific analyses.
Right, and it's clear also that fine-tuning it's not an argument from ignorance. It's not, if you formulate it as there's a problem with fine-tuning, how do you explain fine-tuning? It just sounds like science doesn't know how to explain fine-tuning. And then religious people come in, oh, God did it. But when you formulate it this way, it's fine-tuning is not the problem that we're ignorant about the solution. The mystery of the constants is the problem that scientists don't know how to solve. Fine, wait and see if you have an explanation. They waited decades and they have an explanation. They discovered fine-tuning. Fine-tuning is knowledge. It's scientific knowledge about the constants, how if you change them, there's no atoms. That's knowledge. That knowledge is the solution to a mystery. So the argument of fine-tuning isn't coming from ignorance, it's coming from knowledge to explain a mystery that you're ignorant about. That's not God of the gaps. That's just called good scientific-based philosophy. Okay. There's one other point we want to make, a general broad point that we do differently than everybody else. And I know it seems like there's a lot of questions here, and we'll leave some time for that. The one other point, and it's generic and something inherent about the other approaches that they don't do this. They just don't. But very often, both multiverse scientists and religious people present it as fine-tuning for life, fine-tuning for intelligent life. And multiverse scientists in particular have to do that because their whole approach is to say there's an infinite number of universes. Why are we in the one universe which has all these constants? Because there's no intelligent observers in any other universes. And it's a historical irony that scientists are now forced to formulate that the laws of physics that we observe are a consequence of the anthropic principle. It becomes centered around human beings in a certain sense, around an observer bias. Not because there's any direct purpose, of course, in the framework of atheistic scientists, but in a sense, the observer bias of intelligent observers constrains the laws of nature that we can observe. And religious people want to say that there's fine-tuning for intelligent life because religious people are trying to get divine providence out of this argument. The problem is it's the fine-tuning is really for, when you look at it, it's really for atoms and molecules and stars and galaxies and everything in the universe. And there's a wonderful complex universe in all its grandeur, which has many different types of things, not just intelligent life. And from the fine-tuning argument itself, all you really can show is that there's an intelligent cause that set up the laws of physics and the constants of nature in order to produce a ordered structure universe with molecules and atoms and planets and life and stars and galaxies and everything in the universe. And there's no real evidence from fine-tuning itself that intelligent life in particular was fine-tuned for. Maybe you can argue this since there's some fine-tuning that has to do with carbon. Maybe you could argue that if carbon is only necessary for life, it's not necessary for anything else. So maybe you could say there's a specific purpose of life. I don't know. But in general, it's not really, it's fairly weak, the evidence. And the fine-tuning argument is a very strong argument for God, for an intelligent cause of the universe. And when you try to get too much out of the argument, you kind of lose it. There's a Talmudic saying, if you try to grab too much, you grab nothing at all. You have to sometimes what does the argument give you? And it gives you the strongest argument, in our opinion, in the modern world for an intelligent cause, for God who created the universe, or for a purpose, an intelligent agent. That's pretty good. That's pretty good in the modern world if you can really do that and establish that. And the reality is, if you want to prove divine providence, you have to make recourse to other arguments, which we're just not discussing those things. And I think it's a mistake to try to get everything out of this one argument. You end up exposing yourself again to a physicist saying, well, how do you know everything is made for life? How do you know, maybe everything is made for, human lice? Everything, if without all these things, there's no such thing as human lice. They wouldn't exist. Maybe they're the whole purpose of everything. You end up exposing yourself to all these problems, and then people think, that's a good question. The fine-tuning argument isn't that good. So we think it's important to formulate it properly, the way we, from the mystery to the clue to the idea of an intelligent designer. And it's important to not try to get too much out of it. Be happy if you can really rigorously establish in a clear, compelling way to a person that the cause of the universe is intelligent, and there's something beyond that, set the constants for the purpose of getting a complex universe. We think that's what the argument really shows in a compelling way, and it's important to formulate it without trying to get too much.
Right. Okay. I just want to add one last thing before we move on. Is that this conversation we've had today? Again, we're with a group of scholars, so we got a little more complex, and maybe depending on everyone's background, I know different people might have different backgrounds and different I guess familiarity with fine-tuning argument, and I just don't want to give the impression that our podcast is as rigorous and technical as we've been talking. So it's my job on the podcast we have the give and take.
Yeah, you haven't really done that today.
No, I haven't done that so much. I haven't been cutting them off. But in the podcast, if you listen to it, my job is I'm a math professor in a community college, and my students don't get it, and they've tried to learn math many times, and I'm teaching them things which they've never understood. And it's kind of my job to try to break things down simply to get into the mind of the student. And again, I kind of let Aaron go a little bit and let him get a little more rigorous and complex, because again, we do want to. We think that our argument, on the one hand, is very accessible, and we do a lot of work to try to break everything down simply. The podcast does not sound like we sounded today, but at the same time, we also think we're adding like some rigor to the argument in a way which is not necessarily found in other presentations, and therefore I think we wanted to get that across. But if you didn't fully get all the details of it, that's okay. And if you want to hear, we'd recommend you checking out the podcast Visit the God, or we'd love to have any follow-up questions. Anyone could email us. We'd love to have this conversation in a more, again, I apologize if we got a little bit more rigorous than was necessary, but at the same time,
I thought it was great. I don't think you should be. I think it was fine. Everybody loves complexity.
Yeah. So that's